Welcome to our pre-lab lecture. Today's lab is on chemical reaction 2. We looked at chemical reaction 1 in lab number 4. This is week 7. Lab number 6 in the lab manual is chemical reaction 2. Before we take the quiz towards the end of the session, I would like to first start with a pre-lab for this experiment. You notice that there are possible 56 points, and you may be wondering where the points are. Please make sure you pay attention to each question. I will share my screen and show you what I'm looking for in the pre-lab. In the pre-lab assignment, okay, I want you to pay attention to each and every item on the pre-lab, okay? On the pre-lab, this is question 4, but if you look at question 1, all right, for pre-lab, if you haven't turned in, look at the question, identify. Here is the question on identifying the type of chemical reaction as well as balancing the equation, okay? You should be able to balance the equation and classify. Quite often student means points by just balancing the equation and failing to identify. Subsequent question also has a component, small question in them that you need to pay attention. This is a common one. Here it's talk about, writing the correct chemical formula and underline each element in the compound. You should keep the oxidation state, all right, or oxidation number. So for example, if you just give me the chemical formula for this compound and you fail to give me the oxidation state for each element, which I know you have covered in the lecture, and also by looking at the supplemental material in section 4.6 I did share yesterday, you lose a lot of points in question 2 only. A compound could have 5 elements, and that means you lose 5 points, all right? Just pay attention to that. Look at question 4, for example. It's talk about or asking you to give or to state whether it is soluble or insoluble. I see student just giving me the chemical formula without stating whether the compound is soluble and insoluble, just to raise a red flag that please do not just cruise through and forget to answer the question completely. Let me share my screen here. I think you should be able to see the whiteboard. Let me just see if you can see my whiteboard. Just gonna share my whiteboard here so that at least when I write down the equation, you should be able to follow with me. So any question from last week experiment? Any question? Any question? If there is no question,
Dr.
then
Leica?
yes.
When you were talking about annotating, there's actually a way to directly annotate on the document through Zoom. You can click like view options on the top, and then there's a choice where you can annotate.
Oh, okay, okay. All right. I'll look at that. Thank you for letting me know. All right. Thank you. Thank you. I'll look at that later rather than just using my iPad to show you. Thank you for bringing to my attention. Look at that. So these are prerequisite skill you should know for this experiment. Writing the correct chemical formulas for compound and writing the chemical names. You need to be in a position to do what? To write the chemical formulas, which you should be able to use the periodic table to predict the ionic charges, use the crossover rule, and then balancing the equation. I will not spend time looking at these two prerequisite skills. In chemical reaction one, we look at these types of reaction, which is coming back again. Decomposition reaction, you should know how it look like. Combination reaction, we talked about that. There is combustion, okay? And today we will focus on single replacement reaction and show you how to use the activity series, double replacement reaction, and of course there's an element of redox reaction which involve transfer of electrons from one element to the other element. Please go back to the manual on top hat and read the section on single replacement, double replacement reaction. So let's see the handout, all right, on, I will share the handout, show you how to fill in the data sheet. There will be a simulation I'll share with you through Canvas. You will watch that simulation for part 3.8, and I believe it's also on, let me just see if I'm not wrong, on simulation for this. I should have each section posted on Canvas. Let's see. Here is the module for, all right, here is the module for this experiment. If you look at the videos posted here, it corresponds to each section in the lab manual. Let's say we want to complete section 3.1. This is where you will come, watch the simulation or demonstration and fill in the data sheet here. What do you observe? Remember, from chemical reaction one, evidence of chemical reaction, evidence of a chemical reaction, presence of permanent color change, formation of a precipitate. If there's light produced, if gas is produced, and then you know that a chemical reaction took place when you mix two reagents. So that's what you will be noting down in terms of observation. What do you see? What type of chemical reaction? Is it decomposition? Is it combination? Is it combustion? You may have more than one type, but just give me one. Both will be correct when I look at your script. So that's what I will be looking for in section 3.1. With that, now you'll do the same thing for section 3.2. You will come here and watch the simulation, all right, and fill in the data sheet based on, all right, based on what type of metal being used, copper, magnesium, and zinc. From the demonstration, is there any color change? You're gonna fill in here. I see a student may be writing down using a check mark or using an X to mean that no cars, or just use a check mark. I'll know that that's what you observe. Now, don't miss to indicate a type of reaction, all right? Type of reaction, is it combustion? Is it single replacement reaction? By reading the background procedure, you should be able to classify the types of reaction for demonstration A or test tube A, B, C from the section 3.2 demonstration. All right, section 3.2. If you look at point 2.2.2, it's because of what? Three metals. This could be A, B, C. A, B, C. This could be for magnesium. This could be for copper. Please pay attention which metal is being used. Let's see, activity series. Before we look at section 3.3, all right, how to fill in section 3.3, you need to understand the activity series. Activity series is a list of few selected elements on the periodic table, not all the elements on the periodic table, few selected metals, and hydrogen is included, ranked from the most active to the least active. And I think it's good to share on the, show you where the activity series on, yes, activity series is a list of active metals starting from lithium to the least active, all right? To the least active, you need to, you will refer this. No one will ask you to memorize the activity series listed from the most active to the least active. There is hydrogen, all right? There is hydrogen, even though it is not a metal right here. Pay attention to the ionic charges for metals. It's listed in terms of oxidation. Oxidation, loss of electron. This will lose 1 electron, 2 electrons. Sometimes you may have 3 electrons being lost to end up with a positive. What this means, how, or the element listed at the top, you can think of as most reactive. At the bottom of the list right here is cold, which is the least active or the least reactive. How you read this table is something above will replace something below it in the chemical reaction. That's how this table works. All right. How you use the activity series for single replacement reaction. For single replacement reaction, something above when you write the chemical equation, all right, you use activity series to predict whether the reaction will take place. Let's see an example on how we make use of this activity series, all right? How we make use of activity series here. Suppose we have, all right, lithium plus HCl, all right, and then if we have lithium plus HCl, lithium, you compare the position of lithium with respect to what? With respect to hydrogen on the activity series. And if you look here, lithium is all the way at the top, and it will replace, all right, in single replacement reaction, it will replace hydrogen, and hydrogen gas will be produced. This will form lithium chloride, all right? Remember, lithium is in group 1, chlorine is in group 7, using the crossover rule to end up with the correct chemical formula, plus hydrogen gas. By the way, when acid react with or being replaced, hydrogen, aqueous here, hydrogen gas is produced. Hydrogen gas is produced. And then you need to balance the equation. We need 2 in front of HCl to balance the hydrogen gas, and 2, all right, 2 in front of lithium chloride and 2 in front of lithium. We say the equation is balanced. The equation is balanced, all right? That's how you write the equation and making use of the activity series. At times, it's not always that a reaction will take place. It's not always that a reaction will take place. Suppose we have aluminum plus nitric acid, like that. What will it form? The nitric acid, all right, this is solid. Nitric acid, aqueous. Nitric acid will react with aluminum. If you look at Al, it is above hydrogen, all right? Hydrogen is way below here. That means lithium, aluminum will replace hydrogen in this compound. The product on this side, we have to use the ionic charges, use the crossover rule to predict the correct formulas or write the correct formulas for your compounds. This will form aluminum nitrate, and then use parentheses when you are dealing with what? This is 3 here. When you are dealing with polyatomic ion, you use the parentheses plus hydrogen gas still from gas. This is gas, this is aqueous, and the equation has to be balanced. Equation has to be balanced. This will call for using, let's use 3 here, trial and error. Will that give us the number of hydrogen, 3 nitrate, 3 nitrate? If I look at that, that's not going to work. We have 3. So suppose 2 here, 6, and then we have 6 here. So we need to get rid of this. I mean to say plus, this is 6 right here. So that 2 times 3 nitrate, 2 times 3 nitrate, we have 6 nitrate. We need the 3 in front there, and we need that 2 there. The equation is balanced. This equation is balanced, 2 aluminums, 2 aluminums. 2 times 3 nitrates, we have 6 nitrate, and then 3. The equation is balanced. You have to go back and forth in balancing the equation. Using also the activity series, I've shown you how the activity series works in writing the correct formulas. I don't want you just to say that if it is going to replace, it will be AlNO3, I see this, plus H. Somebody will say the replacement. No, you have to write the correct formulas using the periodic table to predict, and using the polyatomic ion table, all right? Using the polyatomic ion table. Is there any question on using the activity series? Is there any question using the activity series? Margaret, I don't think you'll need to derive the equation. Margaret, I don't think you'll need to derive the net ionic equation, but nevertheless, you should have the skills to balance the equation, right, Neda?
I have a question, Dr.
Yeah,
Lang.
yes, Jose.
Probably more towards the data sheet, but in reference to what you were just showing us.
Yes.
So, for example, if we were to have a nitrate compound and 3, and we were to have to, as the data sheet requires, to write a complete ionic equation, well, we have to break the nitrate into the nitrogen and the oxygen and give its proper charges before we continue, or will the nitrate stay together by itself with a -1 charge?
That's a good question, and that is my next item I'm going to cover right now, writing the net ionic equation. Let's see, to answer your question, I'll use an example to show you how to derive the net ionic equation. Starting from this, let's say lead, I'm just going to form an equation here, lead to nitrate, and this is aqueous right here, plus potassium chloride, like that. And you are expected, this is aqueous, you are expected to write the net ionic equation. Let me even write here, let's say write net ionic equation for this type of reaction. I chose the worded chemical equation to show that you should be able to translate word chemical equation to formulas, and then from there we move out down to net ionic equation. For every chemical reaction, and to this point, what you have been looking so far is the molecular equation. There are three types of equation, all right? There are three types of equation we call molecular, which you will see that molecular equation. There is the total ionic equation, and then there is complete, not complete, this is the same thing, sorry, this is the same thing as complete, all right? Here is sometimes called complete ionic equation. It's the same thing as total. And then the last one here now, which we are going to derive, is net ionic equation. You should be able to differentiate between the three types of equation. And using this example to show you all those three equations is lead to nitrate. You have to predict the formula for lead to nitrate with the ionic charge of lead 2 being positive 2. If it was lead 4, then it's gonna be positive 4. How do I know that it is lead 2? The parenthesis right there. Now coming back to now polyatomic ion, this is now where where you are supposed to recall or even use the polyatomic ion. Each or all general chemistry 1 text, they have a list of most common polyatomic ions. You should be able to predict their ionic charges. You do not split oxygen and nitrogen in this case, nor any other polyatomic ion. Remember, polyatomic ion is a group of atoms with an overall charge, and it acts as one. It reacts as if it is only one. It does not split into respective element in that polyatomic. So we will treat it as one. And with that, what we'll do is I'm gonna write down the formula for my first reagent. And this is the chemical formula for lead to nitrate. I'm using the crossover rule here. I'm using the crossover rule, bring 1 down there and bring 2 down there, and use a parentheses wherever you have the polyatomic ion, and that's why I do have that. Well, as far as this first one here, potassium chloride, potassium is in group 1 with an overall charge of +1, chlorine is in group 7, and of course, this will be now our second one, our second reagent. This is our second reagent. Meant to say K, I, this is aqueous. That is aqueous. The question is, what are our possible products? You can either, all right, this is a double replacement reaction. Double replacement reaction, which means they switch what? They exchange the anions, which can either be polyatomic ion or single. This will combine with what? This will combine, the nitrate here will combine with potassium, and this one will combine with iodide. I think it was iodide. This was, I meant to say chloride. This was Cl. Cl, it was potassium chloride. This is what I'm getting from potassium chloride. And so far, I have my chemical formulas for my reagent. I'll recommend that you use some cartoon if you cannot follow, or if you have difficulty writing the correct formulas of your product. For double replacement reaction, they switch the ions. So for first reagent, I have lead 2 and then the nitrate. We have polyatomic ion nitrate, NO3 with a negative. For second reagent, there is potassium cation, and then there is the chloride. This will help you in writing the correct formulas of your what? Of your product, which means this will combine with chloride, potassium will combine with nitrate, and you can see how the chemical formulas of the desired product will look like. So for lead 2, this will form on this side. This is one of the product, lead 2 chloride, lead 2 chloride, plus what? Potassium nitrate. You don't need to memorize, it's just by using the solubility rules, all right? And not solubility, but crossover rule. To write the correct formulas, crossover rule here, I'm just crossing over. You'll do the same thing for any polyatomic ion. You see, you say, so far I'm not splitting nitrogen and oxygen, I'm just treating it as if it is an element by itself. It's a polyatomic ion. The challenge is when you don't recognize a polyatomic ion. You're expected to have covered that in the lecture, polyatomic ion. There is a table of polyatomic ion. So far so good. Now, you need to write, in order to come down to this last two, this one, total ionic or complete ionic, net ionic equation, we need to balance this equation and we need to indicate the physical state of your compound. Is it solid, is it liquid, or is it gas? Here, I know this is solid. I know this is aqueous. I didn't memorize that, and for at your level, I don't want you to go around memorizing all the compounds which are aqueous and so forth. No, I don't want you to do that. You cannot do that in terms of that's not the best way in learning the solubility. Either here you do what? You refer to the solubility, all right? Either you refer to the solubility of the solubility rules, or use the solubility chart. Use the solubility chart given here. It will give you, all right? It will give you this is the solubility chart. Let me just blow it up this one so that you see how to use. So if you have on this side cations and you have anions or polyatomic ions, you combine the two, and whatever they intersect, you have either as aqueous or solids. Aqueous or solids. All right, aqueous or solids. If it is decomposing, then you will not see that aqueous for AQ. So let's see, for example, lead with chloride. Lead with chloride, I know it is solid, that's why I know it is solid. For potassium and nitrate, all nitrate will be aqueous. Whatever you see aqueous means that aqueous, nitrate. All nitrate are always soluble. So for all group 1, if you don't see any element, you can use the group number because they belong to the same family. So here is group 1, which means potassium is in this group, and when it's combined with nitrate, I do have it as aqueous. That is how you conclude that is it solid, is it liquid, all right? we need to indicate the physical states of your product. Then balance the equation. Before we move on to the second type of equation, we need to balance the molecular. This is the first type of equation, molecular. At the outset, using trial and error, we need a 2 in front of potassium chloride to balance the potassium to chlorine, and then we need a 2 here, and we say the equation is balanced. You need to balance before you move on to the next class of compound. What you see here is molecular. Balanced molecular equation. I had to write the correct formulas and I had to balance the equation. I'm done with this. I'm done with that. Write the correct formulas of your compounds and balance it, and then you are done with the molecular equation. Be it single replacement reaction, you gotta do the same thing. Write the correct formulas, indicate whether they are solid, liquid, or gas. This will be handy when you are deriving the total net ionic equation. Total net ionic equation, I'm just going to write here the second type of class or class of compound here, total ionic equation. How do I derive the total ionic equation? Given, once you derive molecular equation, it is balanced, you have the correct formulas, all right? You use that as the foundation for total ionic equation. And in this is how you will move forward, split only aqueous phase. You only have to split the aqueous phase in molecular equation. You split into ion, not if it is a solid, do not split. If it is gas, do not split. If it is liquid, do not split. And what I mean by splitting is you should see where this polyatomic ion came into the picture. So I'm gonna split the cation from polyatomic ion. I will split the cation from the anion if it is binary ionic compound. Let me show you the splitting. Let me use the same equation here to do the splitting. I will split, look at where I'm splitting. This is where you need to split because there is polyatomic ion nitrate and there is the cation layer 2 ion. I will split here where there is potassium and chloride. The note is leave alone the solid. So I'm not going to split the layer 2 chloride. And then I'll split this one because it is aqueous. So this is what I need to split in order to derive the complete or total ionic equation, so that the subscript changes to coefficient. You see these two here, it will change to coefficient. Here, I don't see anything. So this is how you will now write the total ionic. It will be lead here, and you have to indicate the charge as lead 2, and then indicate also aqueous. It was aqueous plus the subscript now changes to coefficient. Look at what I'm doing, 2 nitrate. And then you have to indicate the charge as well. It is polyatomic ion. The 2 ions came from this first reagent. And then the 2 here for potassium chloride will go, all right, this is plus now 2K positive aqueous plus 2Cl negative. The coefficient applies to both potassium and chloride. It's not only for potassium. So I've split the reagents into respective ions, and please indicate aqueous or if it is solid, leave alone solid. So this is going to be what? Lead 2 chloride, subscript 2, and then you indicate the what? Solid. Plus now, from this product, the last one, I have 2 potassium, all right? 2 potassium, and they are ions now, plus 2 nitrates like that. 2 nitrate like that. And you have the molecular equation. I mean, the total ionic equation. Some others call this complete ionic equation. It's the same thing. Total ionic equation. Any questions so far on how to derive the total ionic equation before I move on to NET? If there's no question, let's move on to the last type of equation we call net ionic equation. All right, net ionic equation. You know, when somebody work 2 jobs or maybe even 1 job, there is the gross income, and then there is the net income. Gross means maybe taxes has not been taken care of. They will show you that this is the net, and then this is the gross, that is the total, and then they take the taxes or any deduction there, and then they say, this is the net, what you will take home. All right, net ionic equation, you cancel here, you have to cancel what we call spectator and spectator ions are they look exactly the same on either side of total ionic equation. We call those spectator ions. They look alike on either side. You cancel, you remove until you see which one is left. Once you take care of the spectator ions, I will go back to the example here, and I'll show you the spectator ions. This is the same as what I have here. It should have been aqueous. So I'm just gonna cancel that, I also see potassium here, look exactly the same as this. I'll cancel this, all right? I'll cancel this and cancel that as well. Lead ion, and it does not, you cannot cancel that. We cannot cancel that. So whatever is left from the total ionic equation after removing the spectator ions gives you the net ionic. So our net ionic now will be PP, that is, and you indicate the physical state as well, aqueous plus 2Cl negative aqueous to give you PPCl2 and then a solid. So what I have here is the net ionic equation, If molecular equation is not balanced, if you end up with using wrong chemical formulas, total ionic equation will be in a mess. Net ionic equation will not come out correctly. So pay attention to the first type of equation right here, writing the correct formulas and balancing. Make sure you write the correct equation and balance it. All right. Use the solubility chart. This one is available on module 7. I uploaded this chart. You can also read about the solubility rules in the background for this lab, there is the section talking about the solubility to predict which one is aqueous, which one is solid. You cancel out that. So going back to the manual now, or before we proceed with that, or say, are we all on the same page now? Did I answer your question?
Yes, sir. Thank you.
All right, thank you. So this is now in section, having gone through that, look at section 3.2. What you will do is you'll write the simulation, you write the observation, and look here, we have 3 chemical reactions. You'll only pick 2. Listen, you'll only pick 2, underline the 2 here, pick any of the out of the 3, write the molecular equation, write the net ionic equation, and complete ionic equation. Attach your workout, how you cancel out. Don't just, fill in and say, I want to see your workout similar to what I'm doing here, how I cancel out the spectator ions, and then you say, oh, this is my net ionic equation. All right, for only 2 of your reaction. And I believe this will be the same thing for the section 3.3. You will watch and see on the simulation. On the simulation, what type of metal is being used? There are several metals. Is it zinc? Is it copper? Is it magnesium? Whatever is used on test tube A or test tube B or test tube C, you indicate the metal here, what metal is being used. Now, you will be given, for example, in test tube 1, you will be given the solution. The solution here, look at the solution. I may have a solution such as AgNO3. This is the solution of the reagent being used here. Anion, and I see students make mistake filling in this, is what is the negative component of the solution given here. If you are given the cation, and by the way, you can see the cation. If you are using ion 2, ion 3, please pay attention to the charges. So if I know the cation, start, and then my anion is NO3 with a negative. This is polyatomic ion nitrate. I don't want to see anything to do with nitrogen trioxide and say that this is my anion. This is my anion. It's not going to work that way. All right. So this is my anion. And then of course, here is the observation. Is gas being produced? Is there any color change? You will indicate whatever observation you will make in each of these boxes. What I wanted to point out is write the chemical formulas for your solution here and give me the anion on this column. That is for what? For section 3.3, and you will pick only 2 out of the 5 to write the molecular equation, which will be balanced, the complete ionic equation, and the net ionic equation. Complete ionic equation and net, only 2. And then of course, based on what you did there, use the activity series. It's in the top half to rank this from the most active to the least active. Only these elements. And I think this is the last. You have to observe which salt is being used, which acid is being used. From the simulation, from the demonstration, indicate what type of salt is being used, what type of acid is being used. Here, write the observation, and for only those reactions which will give you a precipitate, write the molecular equation, write the complete ionic equation or total ionic equation and the net ionic equation. And for those which will form gas, that means bubble will be produced, you'll have to write the correct chemical formula. And be careful wherever you look at the gas, it can be carbon dioxide. All right, it can be carbon dioxide. Please pay attention to that. And you'll submit these through Canvas due next week. Is there any questions so far before I make the quiz available? I just wanted to go through, make sure that you know, we are all on the same page and we know what we are doing when we go fill in the data sheet. Any question? The quiz will be covering on what we just went through. You should have the solubility chart. You should have the periodic table. I did send out the study guide sometimes last week on that. All right. If there's no question, just sit back. I'll make the quiz available in a moment. I'll stop sharing my screen. All right, and you will go online, take the quiz. I will make the quiz available. What time it is right now? It is 1:48. Quiz number 7, activity series. You may need activity series as well. You need a periodic table. Maybe polyatomic ion will help you write the correct formulas. All right. Looking at the time, it is 2:20. Should be done at 2:20 p.m. Should be available now. Please go on quizzes tab 25. I mean, there are questions in there. Please go on to quizzes tab, quiz number 7. Should be up and running. All right, should be up and running now. I'll be on Zoom in case you encounter any problem. Just shoot me a message, DM or direct message.
Professor Lenka?
Yes.
For the quiz, is it set up in a way where we can't go back to the previous questions?
Yes.
We can't?
You cannot.
Oh, okay.
All right, thank you.